Hello friends. In the previous session, my PC was hanged, so I'm continuing with the theory part 4 here over here. The program uses annotations to obtain an array of all annotation. Get annotation is a method that will acquire all annotation associated with meta to class as well as my method. Get annotation returns an array of annotation objects. Recall that annotation is a super interface of all annotation interfaces and that it overrides toString in object class. Okay, annotation is the base interface of all annotation interfaces and it will override toString in object class. Now, when a reference to an annotation is output, toString method is called to generate a string that describes the annotation as the preceding output shows. So when it is overriding it to toString method, it will describe the annotations by its own way. Okay, so object class has already defined its structure of toString method, but when annotation is annotation is overriding the toString method, it will generate a string that will describe a annotation in its own particular way. Annotated element interface. The methods get annotation and get annotations used by the preceding examples are defined by the annotated element interface, which is defined in java.lang.reflect. So base class is java.lang.reflect. It has annotated element interface and it has two methods, get annotation and get annotations. This interface supports reflection for annotations and it is implemented by the classes method, field, constructor, class and packages. In addition to get annotation and get annotations, there are two other methods. One is get declared annotations. It will also return the annotation array. It returns all non-inherited annotation present in the working object. The second is annotation present, which has the general form like this: boolean is annotation present, class annotation type. Okay, so annotation present will return true or false and get declared annotation will give you the array of annotation. Get declared annotation will return all non-inherited annotation present in the invoking object. Each annotation present returns true if the annotation specified by annotation type is associated with the invoking object. Otherwise, it will return false. The get annotation and each annotation present method make use of generics feature type safety. So when we will be learning with the generics, we will be viewing it all in detail. Only generic signature are shown in this chapter in their raw form, so you can have compile time errors or you will have compile time warnings. Okay. So when we will be viewing the generics in detail, so that in that case we will understand in detail. Now we will see the annotation with default values. You can give annotation members default values that will be used if no value is specified. Okay, so you can give a default that is your own value. For example, if on all values are not given a value in your general programs rather than annotations, what default values are used, like 0 if integer I and semicolon is given. So default value specified will be 0. So in some cases, if you don't want the 0 to be initialized, you can specify it like integer I is equal to 10. So 10 is the default value for I. So like this, in annotation also, you can give the default values if no values are present. The default value is specified by adding the default clause to a member's declaration. Its general form is type member default value. An annotation type declaration that includes default. So this is the example for this, and the general format is type, data type, member, default value. So default is a keyword that will be used to give the default value for the particular member's declaration. Interface my annotation. This is the annotation. Its strings default value is testing. Values default value is 9000. This declaration will give a default value of testing to string and 9000 to value. And neither value needs to be specified when my annotation of used. Either or both can be given values if desired. Okay, so it is not like this. If you are giving the default values, it is not necessary that you cannot give the value required. Following are the 4 ways that my annotation can be used. Okay, first is my annotation both string and value default. My annotation string is equal to some string, value defaults at the rate. My annotation value is equal to 100. So value default is some string and string default is 100. Then no default is like string is equal to testing, value is equal to 100. Now we will see how to use default values in detail. In the previous way we have seen string default testing, value default 9000. So now meta3 object is equal to new meta3. We are creating the object of this class. Obtain the annotation for this method and display the values of the members. So this will return you the object. Then c.get method, which method I have to acquire, which method's annotation I have to acquire. It is called as my method. It will be stored in M. Then get particular annotation of my annotation dot class, and this will be written in the my annotation object. Then annotation dot string, annotation dot value will give me the default value specified, testing and 9000, because my annotation is specified with the class meta3. Now my method is called and output is testing 9000. Okay. Then marker annotations. The marker annotation is special kind of annotation that contains no members. Its sole purpose is to mark a declaration. Its presence as an annotation is sufficient. Okay, so marker is a special kind of annotation first of all, and it has no members at all, and it's to it is generated just to mark a declaration. Its presence as an annotation is sufficient. Okay, so it is declared only as an annotation. It has no value, so no need to initialize with the default value or some particular value. The best way to determine if a marker annotation is present is to use the method isAnnotationPresent, which is defined by the annotated element interface. So isAnnotationPresent will give you if the marker annotation is there or not. Now here my marker annotation is created with my method. My marker is here created. Then annotator method using a marker. Notice that no parenthesis is needed, only declaration is sufficient. Then my method created object of my marker, new marker. This is the class, and the object is created. Then object.getClass.get method, my method. This is the method, and determine if the annotation is present. If method.isAnnotationPresent, my marker.class. So it will return you true and your marker is present because marker annotation is provided over here and nothing is initialized inside this opening and closing curly braces. Okay. And if no such method, my method is there, it will catch the no such method exception. Then my method is called over here. My marker is present. This output will tell you that my marker is present in this program. You do not need to follow my marker with the parenthesis when it is applied to a method. Thus, my marker is applied simply by using its name @my marker. When you are creating a method, how you are specifying it using only @my marker. So no need to give opening and closing parenthesis. Then it is not wrong to supply an empty set of parentheses, but they are not needed. Okay. So also you can give an empty set of parentheses. It is not wrong. It will not give you a compile time error, but still they are not required in this case because this is the marker annotation. Then single member annotation. Now, single member annotation contains only one member. It works like a normal annotation except that it allows a shorthand form of specifying the value of the member. Single member means only single, that is only one member. And it is a shorthand form of specifying the value of the member. Interface my single integer value. So this variable name must be a value. And it is the rule that it should have the one member, and that one member will be the value of the member. Then single class is created. @my single value is specified or generated or initialized with 100. Then created the object of this class single. Then get class dot get method my method. It will be saved in object m, and my single annotation is equal to m dot get annotation my single dot class, and it will give me annotation dot value, which is 100. So value is compulsory in the single member annotation, and you will be writing it like this: int value opening and closing parenthesis and semicolon. And when calling or applying, you are giving it with a value 100. And if no such method my method is given, as usual, it will give you method not found exception. That is message, and you can display the exception using plus exception. Here my method is called, and this program displays the value 100 as expected, and my single is used to annotate my method like @my single 100. Value is equal to need not be specified. 100 is a only value because it has only one member. It is a single member annotation. You can use the single value syntax when applying an annotation that has other members, but those other members must all have default values. Okay. Here is the value xyz is added with the default value of 0. So you can add it like this: integer xyz default is equal to 0. Single value syntax can also have other members, but those other members must have all default values. So default keyword is compulsory for other members, and if it is having only single, its name must be a value, and you can initialize or set the value using opening and closing parenthesis and 100. No need to write value is equal to. Okay. In cases in which you want to use the default for xyz, you can apply @sum annotation as shown, @sum annotation at 88 here, by simply specifying the value of value by using the single member syntax. Okay. If you want to use the default for xyz, you can apply sum annotation as shown next. So if we are specifying sum annotation 88 by simply specifying the value of value by using the single member syntax. So here in this case, if I am calling it like @sum annotation 88, so value will be initialized with 88, and xyz will be having the default value, that is 0. Okay. So if in cases if you want to have the xyz to be initialized with the default value, then you need not specify any value over there. You will only specify the value for the value word. Okay. Value parameter. xyz defaults to 0, value gets the value 88. To specify different value for xyz requires that both members can be explicitly named with a value. Okay. If you want to have default value is 0, but if you want to assign other value other than 0, what you will do? You will write it like this: value is equal to 88, because first parameter is integer value. So how you will write it? Value is equal to 88 and xyz is equal to 99. Whenever you are using a single member annotation, the name of the member must be a value. Only value is compulsory over here. You can add as many parameters as you need, but value is compulsory. Then built-in annotations. Okay. Whenever we have created programs before this chapter, before understanding this chapter, that is annotation, we have already introduced the annotation, but we were not knowing about it. Okay. So like for example, @override, it is an annotation. @override that tells that whatever is upcoming next, whatever method is upcoming next, it is a overridden method. that is the extended method from the base class or superclass, and it must be overridden over here. This is just an example. There are many more built-in annotations we will be seeing now. Java defines many built-in annotations. Most are specialized, but 7 are general purpose annotations. 4 are imported from java.lang annotation: retention, documented, target, and inherited. Okay, so 4 from the 7, among the 7, 4 annotations are imported from the packages java.lang.annotation. Which annotations have imported from it? Retention annotation, documented annotation, target annotation, and inherited annotation. And override, deprecated, and suppress warnings are included in java.lang package. So we have not understood or we have not learned about these 4 annotations, but we have already or definitely we have understood or learned about this, seen about this override, deprecated, and suppress warnings. Okay, whenever there are warnings, those can be suppressed over here. Deprecated methods are there, like which methods are not supported from now from latest Java, and override is provided for the overridden method, like I have explained now. Okay, so first is we will see one by one all the annotations. Retention is designed to be used only as annotation to other annotations. Okay, annotation to other annotation. It specifies the retention policy as described earlier in this chapter. Then documented. Documented annotation is a marker interface that tells a tool that annotation is to be documented. Whatever annotation you are creating, that needs to be documented. It is designed to be used only as an annotation to an annotation declaration. Target. Target annotation specifies the types of declarations to which annotation can be applied. Okay. Types of all declarations and to which annotation can be applied. It is designed to be used only as annotation to other annotation. Target takes one argument which must be a constant from the element type enumeration. Okay, it has only one argument, and its argument must be a constant from element type enumeration. This argument specifies the types of declaration to which the annotation can be applied. Okay, the constants are shown here along with the type of declaration to which they correspond. So this constant we will be using with the target annotation. Upcoming constants in the table. Annotation type, another annotation. Constructor, target constant annotation can be applied to. Annotation type constant can be applied to another annotation. Constructor constant can be applied to constructor annotation. Field can be applied to field. Local variable to local variable annotation. Method constant can be applied to method annotation. Package constant can be used for package annotation. Parameter constant can be used with the parameter annotation. Type constant can be used with the annotations class, interface, or enum, that is enumeration. You can specify one or more of these values in the @target annotation. To specify multiple values, you must specify them using the braces, a delimited list, like target element type dot field, element type dot local variable. So there are two constants we have used here, field and local variable, using comma, and whatever you are using, specifying using element type dot constant, comma, element type dot constant, all will be included in the opening and closing curly braces. Then inherited annotation is a marker annotation that can be used only on another annotation declaration. Okay, so since it is a marker annotation, it has no value specified over there. It affects only annotation that will be used on class declaration. Okay, so whatever class you are declaring, in that case inherited will be used, and it will specify that annotation for a superclass to be inherited by a subclass. Okay, so it is generally used in the cases where inheritance occurs. When the request for specific annotation is made to the subclass, if that annotation is not present in the subclass, then its superclass is checked. For example, inherited causes the annotation for superclass to be inherited by the subclass. Okay, So any annotation you are giving with the inherited annotation, any annotation you are creating or initializing or declaring with the inherited annotation, that will tell the compiler or Java virtual machine that this annotation is @inherited annotation, and for that purpose it should be inherited, it can be inherited by the subclass. And when the request for a specific annotation made to the subclass, if that annotation is not present in the subclass, then its superclass is checked. So whenever you are calling with the subclass object and you are checking the subclass for that particular annotation, since we have provided the inheritance @inheritance annotation over there, if that annotation, that particular annotation is not present in the subclass, it will be checked with its direct superclass. If that annotation is present in superclass and if it is annotated with @inherited, and then that annotation will be returned in this case. Okay. So this way we have understood inherited annotation. So now we will be viewing the annotations from the java.lang package. First is @override. Is a marker annotation that can be used only on methods because methods can be overridden. A method annotated with @override must override a method from a superclass. So whenever you are providing override, it is a compulsory that you must override a method from its superclass. And if you are not overriding, it will give you compile time error. It is used to ensure that superclass method is actually overridden and it is not simply overloaded. Okay, overridden means your method name should be same, parameters should be same, parameter data type should be same, parameter sequence should be same, as well as parameter number of parameters, length of parameters should be same. And if it is overloaded, that means method name is same but number of parameters are different or type of parameter are different, like that. But override annotation will not take this. That method must be overridden in this case. Deprecated is a marker annotation. It indicates that declaration is obsolete and it has been replaced by the newer form. Whatever that you are using, that is deprecated. Whatever method that is you are using, it is deprecated, means it is no longer used from nowadays. Okay, so it is a old way of writing a method, or it is a ban method from Java. So that will be declared with the deprecated annotation. Suppress warnings specifies that one or more warnings that might be issued from the compiler are to be suppressed. Whatever warnings compiler are giving, you can suppress them. The warnings to suppress are specified by name in string form. The annotation can be applied to any type of declaration. Okay. So in your Java program, there can be many types of error, and in that type of error, many type of warnings you can have. In that case, the warnings can be for classes, for constructor, for field, for method, or for anything, for inherited class, for enums, or anything that you are having in your program. So for all types of fields, you can use the suppress warning annotation. Now we will see some restrictions. There are number of restrictions that apply to annotation declaration. No annotation can inherit the another annotation. You have to remember this. If you are not able to remember, it is possible you can remember this, but if you are feeling it hard to remember, you can write it down. No annotation can inherit another. All methods declared by annotation must be without parameters. Okay. All methods declared by annotation, because annotation may or may not have parameters, but still methods must be without parameters. Only opening and closing parentheses will be there, and they must return one of the following. It must return a primitive type int or double, or it can return object of type string or class, or it can return enum type. It can return another annotation type. It can return array or of one or more, one of the preceding type. Okay. So array of primitive type, array of object, array of enum, array of another annotation type. So they must not have parameters at all, and they must return 4 or 5 of the elements. Annotations cannot be generic. They cannot take type parameters. Okay. Type parameters. Generics are described later. And finally, annotation method cannot specify a throws clause. So whenever there is an error or if it is handling the try catch, it must handle that exception. It cannot throw that exception to other method. So it cannot specify the throws clause. Okay. So you can go through the errors. Sorry, you can go through the restrictions and then you can decide. You can write it down to understand these restrictions. So this way we have finished with the enumeration, autoboxing and annotation. Now I have referenced the book Complete Reference, Herbert Shield. This book I have learned Java from, I have understood Java from, and whatever notes I have taken from this book. It is very easy to understand. I am very much thankful for this book and I am very much thankful for these icons also. So I am attributing them. Please, you can go through this icon. You can view them. These are the icons from Flat Icon website I have taken. And these all icons I have used in my all PPTs from chapter 1 till now. These are very interesting and attractive icons that made my PPT better. For that, I am very much thankful for all these icons. I am very much thank you to viewing my video. If you have any doubt, you can personally message me or you can ask me. Okay, and we will be viewing the practical part in the upcoming session. So meet you in the next session. Thank you so much.